All right, folks, today we're going to talk about some probability stuff. In order to talk about probability, we have to know about totals or number of ways to do things given a situation. So we're going to deal with the multiplication counting principle, what we call permutations, and what we call combinations. Our first thing we're going to look at is the multiplication counting principle. And kind of like it says, it's going to involve multiplication. Okay, so here's the idea. If decision M can be made M ways and decision N can be made N ways, then the two decisions together can be made M times N ways. Right? It seems a little bit messy, but what I'm going to do is explain it kind of using this first example here. It says the ice cream shop offers a choice of 3 different cones sizes, like small, medium, and large. They have 15 different flavors and 8 toppings. What we want to decide is how many different cone combinations are possible if you can only choose 1 flavor, 1 topping, and of course 1 size of cone. Okay? Before we get to this 3 cones, 15 flavors, and 8 toppings, I want to relate it to this M times N. We are making more than 2 choices here. We'll have 3 separate ones. And I want to explain why we can just multiply the different options together using a smaller example. Okay, so I'm going to keep the 3 cone sizes, small, medium, large, but I'm going to cut down the other to kind of give you a visual here. So suppose we only had 2 flavors, chocolate or vanilla, and we only had 2 topping options, sprinkles or peanuts. How this would look is we could get a small cone and have chocolate or vanilla with the sprinkles and with the peanuts, or we can have a medium cone, chocolate, vanilla, sprinkles, peanuts, or that same thing with the large. And you can see there's 4 different ways to have a small cone, 4 different ways for medium, and 4 for large, for a total of 12. But where that comes from and how it ties into the multiplication counting principle is we had 3 choices to make. We had the cone size, the flavor, and the toppings. There were 3 different choices for the cone size, 2 for the flavors, and 2 for the toppings. If we multiply all those together, we get 12 without having to list them all out. Okay, so that's what we're going to do on number 1 here. We've got 3 different groups, so I want you to put 3 blanks on your paper. Because it's multiplication counting principle, we'll multiply between them, and we'll just talk about how many options are for each group. So cone, we have 3 options. Flavors, we have 15, and toppings, we have 8. And all you have to do is go type that in your calculator. That comes up with 360 different types of cones. Be sure we answer our question with a label based on what it asks for. And that would not have been as fun to list out all of those options. Okay, so it's good we have this principle to shortcut for us. We're going to follow that same process on number 2. It says Virginia license plates consist of 3 letters followed by 4 digits. So we're starting out just drawing some blanks. So we've got first letter, second, and third, and then 4 digits, 1, 2, 3, 4. Okay. From there, we're going to talk about letters first. It didn't tell us how many options there were because we are supposed to know. So letters in the alphabet, there are 26 different ones. Okay, so there's 26 for the first one. Now, they didn't tell us that the second digit or the second letter had to be a different one, so there are still 26 for the next one, and there's still 26 for the next one. Okay, then the 4 digits, we have to think about digits going from 0 all the way to 9. 1 to 9 has 9 numbers. Add in the 0. There are 10. Anytime you see this digits, we've got 10 different options. So then we've got 10. Again, repeats are allowed, so 10 all the way through here. And I want you to get to a point where you can kind of write these a little bit better. If we've got 3 letters, and they're all going to be 26 options, we can write this as 26 to the 3rd power, and then group the other ones the same way. We've got 4 different 10s, so we can write that 10 to the 4th, which makes it a little bit easier to type in. Okay, so go ahead and take a minute to type that in your calculator. And we should get 175,760, and then 1,000 plates. Okay, so there's almost 200 million different options there, so they're not going to run out of different numbers using that method. All right, so read through number 3 for me. Okay, Nick's science test has a section with 12 true or false questions. I should say or. How many ways can Nick answer these questions? So we're making 12 different selections here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a good example of when we want to be able to combine it using powers, kind of like what we did on the last time. So here, we've got true or false. So on the first one, there are 2 options. You could have true or false. And then on the second one, it doesn't matter that you selected true. It's still true or false on the next one. So all of these get 2 different choices, meaning we're going to have 12 different times. Okay, so 2 to the 12th for that one, which is 4,096 different ways to answer the test. And let's go ahead and put a box or a circle around our answers for these. Now, what we're going to talk about next is a little bit weird. We're going to see this exclamation mark. That's actually called a factorial in math. So in exclamation is in factorial. And it says it's the product of natural numbers from 1 to n. Okay, our natural numbers are our counting numbers. So if n was 5, it'd be 1, 2, 3, 4, and 5. And product means we're going to multiply them all together. Now, what we generally do is actually start at the number and count down. So for this one, because it's 4 factorial, we'll start at 4 and then count down from there. So times 3, times 2, times 1. Just make sure you stop at 1. And then some of these we'll be able to do without a calculator, but some will need a little bit of help. We've got 12 times 2, and that's 24. Okay, 11 factorial is going to be the same type of process, just a lot more numbers. We're starting at 11, and we're multiplying by all the natural numbers that fall below 11 until we get to the number 1. Okay. Now, I am going to show you something on your calculator, and it's going to be helpful as we go through these problems. Factorial is actually built in on your calculator. Obviously, for us, 4 times 3 times 2 times 1 doesn't take a lot of time, but typing in 11 times all those numbers would be a little time-consuming. So what you can do is start with the number you need. Ours is 11, and then factorial actually falls under this math button. So click math for me, and then at the top, way at the right, PRB stands for probability. If you go over there, it's the 4th option down, and you can just click 4. And then that'll give you that product for you. So we've got 3, 9, 9, 1, 6, 800. Okay, I want to talk about 6 because it's special and it's going to tie into what we'll talk about next. With number 6, we've got a 17 factorial on the top and 11 factorial on the bottom. I want to talk about how we can express factorials in a lot of different ways. Okay, so don't write anything yet, just bear with me for a second. 17 factorial, we know, is 17 times 16 times 15 and so on. Okay, but we can express it in a lot of different ways. We can take 17 and multiply it by 16 factorial because that would cover all those numbers to the right. Similarly, we could take 17 times 16 times 15 factorial, meaning essentially we can peel off those numbers until we want to stop at any number we want to stop at. Now, how that's useful is when we have division, we like to stop at what shows up on the denominator so we can cancel stuff out. So, on this one, how I want you to write it, let's start with 17, multiply by 16, and we're going to go all the way till we hit that 11. So 15, 14, 13, 12, 11, and instead of keep going, okay, 10, 9, 8, 7, we can just throw a factorial on the bottom. Has another 11 factorial, and then those cancel out. So now all we have to put in our calculator is that 17, 16, 15, 14, 13, 12 to get 8,910,720. Now, of course, you can use your calculator with this one as well. Your 17 factorial, and skip to number 4, divided by your 11 factorial. The reason I showed you to do it by hand is there are some numbers, not in this case, but there are some numbers that when you type in a factorial, it's actually too large for your calculator to multiply those numbers, so sometimes you have to do a little of it by hand. Okay. On this last one, I'm going to go ahead and type it in, 0 factorial, and then we'll talk a little bit about why it's important. Okay, so you'll notice 0 factorial is 1. Okay, and a really big idea of 0 factorial comes with the formulas that we're going to see here in a minute. For right now, I just want you to really emphasize that when we're talking about factorials, we want only natural numbers, and 0 actually isn't a natural number. So this is defined as 1, and we'll see why using our formulas starting on the next section. So all of these factorials are going to be super useful for us to simplify when we're talking about both permutations and combinations. So permutations are up first. It says an arrangement of R objects selected from N objects without replacement where order matters. So these two things are going to be the most important for us to remember. Without replacement changes the process of what we were doing on the first section. The multiplication counting principle, when we were talking about that true and false test, if you pick true on the first one, you could still pick true for the second one. That's not going to be a fair game when we're talking about a permutation or when we're talking about combination, because we're not going to replace our objects once we select them for the first time. And we'll see why that matters and what kind of situations produce that. And then order matters is going to really tie into this without replacement type thing as well. So I'm actually going to come back to this formula here. We'll talk about it in a minute. We're just going to skip to problem 8 and kind of solve it the way we did with those ones up above, just with an extra twist. So it first starts out saying, how many ways can you arrange the letters in the word dinosaur? So two things make this a permutation. Arrange, by definition, means to order something, so that's the order matters. And when we're talking about arranging these letters, okay, there are no repeats. And they are going to be mixed up on your homework, so it's important that we talk about those two items, if repeats are allowed and if order matters on every single one of these. Okay? Then with that, we want to arrange all of the words, because they didn't say just, or all of the letters, they didn't just say a couple of them, so we need to count how many are here. So we've got 1, 2, 3, 4, 5, 6, 7, 8 letters, and we are choosing all 8. So that means 1, 2, 3, 4, 5, 6, 7, 8 different blanks. Okay, so we want to choose the first letter, and the first letter we have 8 options from. But because no repeats are allowed, suppose I chose a D, that means it's no longer available for my second choice. So I wouldn't have 8 for the next one, I'd only have 7. And that pattern continues for the next selection. I have 6, and then 5, 4, 3, 2, and 1. So a better way to write this, when you take 8 and go all the way down, is 8 factorial, which is a little bit faster to type in, just like with our powers. Okay, so in your calculator, just your 8 factorial, hit your math, over to probability, and then number 4, and that'll give us 40,320, and it says how many ways, so ways. And that's it. Okay. The next one, it says 7 students are competing in a geography bee. How many ways can they finish first, second, and third place? So we've got 3 selections to make, first, second, third. That helps you to label those. Do that. And we want to know how many choices do we have for first place, how many for second, and how many for third. So we had 7 students. That means there's 7 for first place. But once someone's got first place, they can't also come in second, so there are no repeats. Okay, and order does matter because first, second, and third mean different things. Okay, so this process, 6 for the next, and 5 for the one after that. Multiplying those through, we get 210 ways. All right. For this last one, we're going to do it 2 different ways so I can show you how this formula works as well. It says Melanie is taking 4 classes this semester. So we've got American History, Algebra 2, AP English, and Chemistry. How many ways can these 4 classes be arranged on her schedule? She's not going to take American History twice, so that makes it no repeats. And order matters because of that word arranged. So we're doing the same process we have been doing. Okay, there are 4 classes for first hour. But once first hour is done, we only have 3 for the next, and then 2, and then 1. Okay, so that is 12 times 2 is 24 different ways. Now let's talk about this formula. NPR, when we see the N is talking about total options. Okay, and the R is talking about how many we pick. So sometimes we choose all of them. So like on number 8 and number 10, we had 8 choices and we chose all 8. This one we had 4 choices, we chose all 4. But sometimes, like on number 9, we don't choose them all. We had 7 people and we only chose 3 of them. Okay, so for this one, we had 4 total choices, 4 classes, and we wanted to select all 4 of them. So this is 4P4. And that would look like N was 4, so 4 factorial. And on the bottom, we had 4 minus R, which would be 4 minus 4 factorial. Remember, from up above, 0 factorial is the number 1, and 4 factorial is left, and that's how we wrote it out. Okay. One more thing I'm going to show you is your calculator also builds this in. A lot of time for permutations, it's easier to draw out blanks than to write your 4P4, but you're also welcome to do it this way. Okay, what I want you to do in your calculator is start with the number 4, and this permutation formula is built in. You won't ever have to write out the formula as given here, but I wanted to show it to you for that 0 factorial. Okay, so then you hit Math, and over for probability, the same place that we saw the factorial, you've got this NPR. So go down to that, hit Enter, and then we'll put the R value as number 4 as well. And it gives you that same 24. So you are welcome to use this, but you have to write 4P4 if you do use that formula. Okay? And that's it for permutations. The last thing we have to talk about are combinations, and this also has without replacement, but order doesn't matter, which means there's a lot of extras we have to get rid of. If you notice the formula, this part is just filling in the blanks. Okay, we learned that from the last one. But we also divide by R factorial. That essentially just gets rid of all of those repeated values. Okay, for these ones, when they're combinations, when we decide that, we're going to use our built-in formula on our calculator to speed up the process. I will show you just once using this formula for this first one. Okay, so Natalie has 16 close friends. How many ways can she choose 5 to be bridesmaids in her wedding? Okay, so we're choosing 5 from 16. We can't have repeats because that would mean one person is being 2 different bridesmaids, so that doesn't work. Okay, but order doesn't matter is because they're all bridesmaids. It's just a group having the same job. So how they line up doesn't matter. Okay, that makes it a combination. So what we're going to do is decide what N is and decide what R is so we can fill this in. Remember, N is your total, so that's your bigger number. And then we're choosing 5. So this would look like 16C5. And on top, we'd have that 16 factorial. On the bottom, we'd have 5 factorial, and then 16 minus 5 factorial. Okay, to simplify this, I'm going to leave this 16 factorial alone for right now, and we're going to just subtract this part. So here, 5 factorial stays, and then we've got 11 factorial. So just like we did with the factorial problems on the front page that were division, we want to peel off the top until we see something on the bottom, and we're going to go with the bigger one. So 16 times 15 times 14 times 13 times 12 times 11 factorial, and then 5 factorial, 11 factorial. Those cancel out, and this is something we can type in our calculator, just like we see it. Okay, so you're starting off with your 16 times 15 times 14 times 13 times 12. Okay, and then we want to divide by the 5 factorial. Okay, so 5 over to your probability factorial. And that gives you 4,368. And that's ways to choose bridesmaids. Okay. I'm also going to show you calculator way on this because that's how we'll do it from now on, because this wasn't a whole lot of fun to simplify. Remember, you start with 16. Always what comes first is what you write first. Then hit math, over to probability. This time it's a combination because order didn't matter. And then we can type in the number 5, and we match that same number. Okay, so you see how the formula works. It's already built in your calculator. You get to use this formula as long as you write down what you type in. Okay, so we'll do that for the next one. It says, what if she already decided on 3 of the 5 bridesmaids? Okay, how many ways would there be to choose the remaining 2? So once again, we have to take into consideration without replacement, because we're still not going to have a bridesmaid be 2 different bridesmaids. And then also, order doesn't matter again because they're not specific jobs. They all have the same. So we've already decided on 3 of the bridesmaids. So that means we're taking our 16 and decreasing it by 3. So that means my N is only 13 now because 3 are already gone. Okay, but similarly, we don't have to make 5 choices anymore. We've taken 3 of them out. We only have 2 choices. So this would look like 13, then C, 2. And that's something you can type in. Okay, practice that now. Hopefully you got 78 ways. Okay. Last one, it says there are 24 students in Kyle's kindergarten class. How many ways can he choose 8 to attend his birthday party? Once again, we've got 8, we've got 24. No repeats because the same person means just one person. No repeats there. And it's a group of 8 people. They don't have specific jobs, so it's a combination. We're starting with the N value or the total, the bigger number, 24, and we're choosing 8. So this would look like 24, C8. We'll type this one in together. 24, math, over to probability, combination, and 8. So this is 735,471 ways. All right. 14 through 21 are all mixed problems. Here's kind of the process is you decide if repeats are allowed. If yes, you fill in the blanks. The numbers repeat themselves. If no, order matters. You're using a P permutation. You can do it in your calculator in PR. And if order doesn't matter, because it's just a group, then you're using a combination and using your calculator in CR. Okay, so what I want you to do is pause the video and try 14 through 21 for me, okay, and I'll go through the answers when you come back.